Today we're going to talk about slope-intercept form. We've talked a lot about slope. It describes the steepness of a line. So if we are given an equation where we can identify the slope, we can use that information to help graph the line without making a table of values. So basically today we're going to talk about another way to graph lines. And let's just remind ourselves two other methods we've practiced. One, you can always create a table of values that make the equation true. And two, the other way is to find the x and y intercepts. And you can graph those if you know where a line happens to cross the x-axis as well as the y-axis. Those are the only 2 points that you need to draw your line. And remember that the line represents all of the points that make your particular equation true. And we are working with linear equations, hence the lines. The two special cases we have talked about are horizontal and vertical lines. So let me just remind you that a horizontal line, remember, horizontal looks like this. Make sure we got that down. So with the horizontal line, that's where x equals a certain number. Maybe x equals 1, x equals 2, x equals -5. X equals 0 happens to be the x-axis. We must also recall that the slope of a horizontal line equals 0. And a good way to come up with different points is to create a table. Okay, so that's one of the special cases we've talked about. The other is a vertical line. That, of course, goes up and down. That's the equation is y equals some number. I could put those in boxes because those are the equations we would be given. And in this case, the slope is undefined. But again, we could make a table of values. You can choose anything for x, but you always know that y equals that certain number. And therefore, you can graph your vertical line. Vertical lines, remember, do not represent functions, but horizontal lines do. So that's just something I wanted to reiterate. So, what is this slope-intercept form business? Let's go ahead and write that down. Slope-intercept form is when an equation is written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So let's go ahead and get that down. All equations of the form y equals mx plus b, where m is the slope and b represents the y-intercept. You might say, well, what does that mean? Basically, it's whenever you have an equation that is solved for y, and you have x by itself on the other side. So y equals 2x. Let's look at that for an example. Y equals 2x. You'll also note that this type of equation is actually in direct variation format. So k equals m. K and m both represent the slope. This is not quite in slope-intercept form just yet because we're missing a b. So the question is, what would b equal? What is the y-intercept in all direct variation equations? Well, if you recall, it turns out that b is always the origin 0, 0. The y-intercept for all direct variation equations is at 0, 0. So I could rewrite y equals 2x as y equals 2x plus 0. And now I am in what we call slope-intercept form. So we've already been working with equations like this. We just didn't know it. In this equation, the slope is m, which is 2, or I might want to write 2 over 1 so I can see the vertical as well as the horizontal change, and I can say that the y-intercept is 0. Now, it's always really helpful to remember that the y-intercept is written as a coordinate like this, where 0 is your x-coordinate and y is whatever number b happens to be. So it's really like this for the y-intercept. In this case, as I was just saying, it's 0, 0. So how can we use these two pieces of information to graph a line? Well, you can make a quick and dirty sketch. It's okay if it's not perfect, this being your notes. Okay, but let's just quickly draw an x and y axes. Always label x and y. I have a slope of 2 over 1, and I have a y-intercept of 0, 0. 1, 2, 3, 4. I'm just going to go out to 4. 1, 2, 3. Negative 4. 1, 2, 3. Negative 4. And 1, 2, 3, 4. Okay, so something like that. Well, this is what you want to do. First, you want to graph the y-intercept. Secondly, you want to use the slope from the y-intercept to find another point on the line. That's it. You might want to do it a few times just to make sure that your line's pretty straight, but in the end, you can draw your line, connect the points. So, how does that work here? Well, 0, 0. Okay, I know my origin is right there. So I'm going to use a slope of 2 over 1. Now remember, 2 represents the vertical change, 1 represents the horizontal change. Since these are both positive, we are going to be moving in positive directions. So we're going to move up 2 and over 1. Be careful with your axes. If you're counting by ones, you can easily count the boxes. I can go up 2 boxes, 1, 2, over 1, and there's my point. Then from this point, I can use the slope again, up 2 over 1, because slopes of lines are constant. I can go up 2 over 1. This works because I'm counting by ones. If you were counting by twos, you'd have to be careful. I could only go up, 1 box and then over half a box, and up 1 box and half a box. So just be cognizant, be aware of that, that you can't just always count by ones if your axes don't happen to be counting by ones. So up 2 over 1, up 2 over 1. It's a little bit tricky to draw nice straight lines on my tablet here, but let's go ahead and do our best to connect these points. Maybe I'll use my little line maker. Okay. So this is my line. Okay, up 2 over 1, up 2 over 1, up 2 over 1. I could also go backwards. I can go down 2 to the left 1, down 2 to the left, down 2 to the left. That's kind of like doing this, negative 2 over negative 1, which equals 2 over 1. Okay, but I didn't have to create a table. I didn't have to find, of course, there were no other intercepts. So it was a quick and easy way to graph this line. Let's just take a look at another example. So let's say I gave you an equation that looks like this. Y equals negative 3/5 x minus 7. Okay. First thing I would do is change your minus signs to plus negative so that you recognize that you have a negative 7. This is in the form y equals mx plus b. I don't have to manipulate it. I don't have to add a 0 anywhere. So let's go ahead and label m. m is negative 3/5 and b equals negative 7. Now remember, we want to write it as a coordinate because that's what we're graphing. So I'm going to graph 0, negative 7. Okay, so that's my b. My slope, be careful with your negative sign. It really doesn't matter where you place the negative, but the negative means that you have to move in the opposite direction, and you're only going to do that either with your vertical change or with your horizontal change. You can't do it to both, because otherwise you'll end up with a situation that we had before, like a negative over a negative equals positive. So I'm going to assign the negative to just the numerator, and instead of going up, which is positive, I'm going to go down, which is negative. 5 is still positive, so I'm going to move to the right. That's where people tend to make mistakes. It's with those negatives, and they're not quite sure if they need to move up or down or left or right. If it's all positive, you move up. I won't use an arrow. Let me do this. If you have a positive slope, you move up and to the right. And typically, with a negative slope, you move down and to the right. That's how I tend to do it. There are other options. I just don't want to confuse you. So if you want to stick to these two rules, you'll be good to go. Okay, again, let's just draw a quick set of axes here. My numbers are a little bit more funky, so just do your best with this. I have X, I have Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10. You know what? It might be better if I count by twos, but let's see what I do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. The reason why I'm saying this is because I know I'm going to have to start down at 0, negative 7, and then I have to go down 3 and over 5. It will just barely fit on my graph, but maybe counting by twos would have been a little bit better. We can always adjust our axis or axes if needed. Okay, so first thing, what do we need to do? We need to graph the y-intercept, 0, negative 7. 1, 2, 3, 4, 5, 6, negative 7, right here. Always make sure that you are starting with that point. I am not starting at the origin because the y-intercept is not 0, 0. The y-intercept is negative 7, so I have to cross the y-axis at negative 7. Now I'm going to use the slope, and from this point I'm going to go down 3 and over 5. So 1, 2, 3 and over. 1, 2, 3, 4, 5. So again, I'm moving down 3 because it's negative, and to the right 5. I could do it again, 1, 2, 3, 1, 2, 3, 4, 5, but I have grid paper, and you might be working on lined paper, so you know, you might not be able to do that. Let's go ahead and draw our line, and I'm just going to extend my line as well. Okay, I want the line to go as far as possible. Okay, again, it's not totally accurate there, but you get the idea. This is what our line is going to look like. Please make sure you are using straight edges in your book work and on any type of assessment. For notes, it's okay to be a little bit sloppy, but we want to be very accurate when we're actually working through problems like these. So there we go. That's another way to graph using slope-intercept form. The only other piece I want to show you is that you're not always given equations in slope-intercept form. So let's say you were given 5x plus y equals 3, and I want to know what's the slope and what's the y-intercept. Well, you cannot tell me that the slope is 5. And you might say, but why not? It's right next to x. And the reason why it's not 5 is because this is not yet written in slope-intercept form. It is not in y equals mx plus b form. So we cannot yet answer what the slope and the y-intercept happen to be. In order to answer those questions, we need to rewrite this equation. And basically, to rewrite it, we need to solve for y. So let's do that now. 5x plus y. I want to get y alone. How can I get y alone? I can subtract 5x. That gives me y equals 3 minus 5x. 3 and 5x are not like terms. And I'm still not in y equals mx plus b format, but I'm pretty close. I'm going to rewrite this as plus negative so that I recognize that my 5 is negative and not the 3. Then I'm going to use the commutative property and restate it as y equals negative 5x plus 3. My slope is negative 5, or negative 5 over 1, and my y-intercept is 0, 3. Then we could graph from here. We're going to practice this in class, so I think we're all set for now. I will see you tomorrow. Thank you. Bye.